Okay, so here we go, lesson 2.6. And okay, so we're going to explore today relationships of angles formed by a transversal cutting parallel lines. And the vocabulary words that should be in your notebook by the end of the lesson are transversal, corresponding angles, alternate interior angles, and alternate exterior angles. As a launch, what do you notice about the ladders and the platforms on the photo? Well, the platforms look parallel, and the ladders are intersecting the platforms. Which angles look congruent? Well, I already marked them here, but the green highlighted angles kind of between the two platforms and on the opposite side of the ladder look parallel. And then the angles on top of the platform and between the platform and the ladder look parallel. And explain how you know and how you identify the angles. Well, I could say like on opposite sides of a ladder or below or above the platform, that kind of thing. Okay. This is a very important slide to make sure that we get in your notes. So that diagram to the left that says transversal. Again, if I have two parallel lines, these are parallel lines, and they're cut by a transversal, then there are some vocabulary words to describe the relationship between the angles on the top and the angles on the bottom. So angles 1, 2, 3, and 4, how are they related to angles 5, 6, 7, and 8? So corresponding angles, an example of that is angle 1 and angle 5. They correspond to each other. They're like in a similar location. So another one would be 2 and 6, and 4 and 8, and 3 and 7. Alternate interior angles, interior meaning they're inside. So like if these are platforms, they're on like in between the two platforms, right? Or they're in between the two lines. And example would be 3 and 6. They're on alternate sides of the transversal. So 3 and 6 or 4 and 5. And then alternate exterior, like they're above and below, above the top platform, below the bottom platform, or above the top line, below the bottom line. And those are going to be angles 3 and 6. Or pardon me, angles 2 and 7. Angles 2 and 7 are alternate exterior angles, or angle 1 and 8. All right. So when parallel lines are cut by a transversal, there's a special relationship among the angles. Let's investigate. Okay. So this investigation is going to explore the relationships among the angles on the top to the angles on the bottom. So specifically angles 1, 2, 3, and 4, and angles 5, 6, 7, and 8. So using the lines on paper as a guide, draw a pair of parallel lines. So you're going to do this in groups, and you make sure you need lined paper, straight edge, patty paper, and protractor. And you're going to draw the diagram you see on the right. And you're going to label the parallel lines K and L and draw a transversal that intersects the parallel lines, label the transversal M, and label the angles with numbers as shown at the right. Now place a piece of patty paper over the set of angles 1, 2, 3, and 4. Copy the two intersecting lines M and L and the 4 angles onto patty paper, and translate or move the patty paper down to the intersection of lines M and K. The translation vector is a segment of the transversal between the parallel lines. Compare angles 1 through 4 with the corresponding angles 5 through 8. What do you notice? What's the relationship? Okay, and then compare the alternate interior angles. And that may require rotating the patty paper to compare the alternate interior angles. What about the alternate exterior angles? And if you need a reminder of what those are, go up here and it shows you a list of all of them. So you need to test like, how does 3 and 6 compare? How do 4 and 5 compare? How do 1 and 8 compare? So on and so forth. When we do that, we compare our results with the group and complete the conjectures below. And so we're going to notice that they're all congruent or equal in measure, and all of the conjectures just have the word congruent on them. And so the corresponding angles, the alternate interior angles, the exterior angles, they're all conjectures, what we notice from inductive reasoning. And the last question is, what happens if the lines you start with are not parallel? Check whether your conjectures will work with non-parallel lines. And so if we draw the lines that aren't parallel, they clearly don't look congruent. They're clearly not congruent, and that's what we find. The conjecture is not true. Have to be parallel. Next, in the next investigation, what about the converse of each of the conjectures? Suppose that you know that a pair of corresponding angles or alternate interior angles is congruent. Will the lines be parallel? Is it possible for the angles to be congruent, but for the lines not to be parallel? So let's see. You're going to draw two intersecting lines on your paper and copy these lines onto a piece of patty paper. Because you copied the angles, the two sets of angles are congruent. Slide the top copy so the transversal stays lined up. Trace the lines and the angles from the bottom original onto patty paper again. When you do this, you are constructing sets of congruent corresponding angles. Mark the congruent angles. Are the two lines parallel? Meaning they'll never meet, right? So when you're doing this, you have it, and I slide it down, and I can see they're definitely congruent. And what I can do is, using my ruler, can kind of mark here, 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 and then draw a line in between there. Okay. Are the lines parallel? Yep, they are. And repeat step one. This time, rotate your pad paper 180 degrees so that the transversal lines up again. What kind of congruent angles have you created? Trace the lines and the angles and mark the congruent angles. Are the lines parallel? Check them. And so again, I can mark these angles congruent to each other. And then these angles congruent. And these congruent. And these congruent. There we go. Repeat step one. That's going to be done on a different lines here. And 1, 2, 3, 4. Trace, trace. 1, 2, 3, 4. Go down, line up. And there we go. And we have okay. These are parallel to each other. They are. What we notice is that these are congruent and these are congruent. These are congruent. So I'm just doing it on paper right now, and I'm noticing that they're congruent. Great. And cool. So compare your result to your group. We're going to notice that if two lines are cut by a transversal to form pairs of congruent corresponding angles, congruent alternate interior angles are congruent alternate exterior angles, and the lines are parallel. There we go. Cool. Next, we're going to develop proof. You will use inductive reasoning to discover all three parts of the parallel lines conjecture. However, if you accept any one of them as true, you can use deductive reasoning to show the others are true. Read the example on the next slide. Before we read the solution, write a deductive argument with your group. Remember the reasoning strategy of applying previous conjectures and definitions. Then compare your solution to the one presented. Write a deductive argument explaining why the alternate interior Engels conjecture is true, assuming the vertical Engels conjecture and corresponding Engels conjecture are both true. This diagram here will be helpful. Deductive argument. In the diagram, lines L and M are parallel and intersected by transversal K. If the corresponding Engels conjecture is true, the corresponding angles are congruent. If the vertical Engels conjecture is true, the vertical angles are congruent. Because both angle 2 and 3 are congruent, angle 1, they're congruent to each other. Okay? And so basically, we're going to say, okay, I know angle 1 is congruent to angle 2 because they're corresponding angles. And I know that angle 1 and angle 3, because they're vertical angles, because they're both equal to congruent to angle 1, they have to be congruent to each other. Therefore, I've shown that alternate interior angles are congruent. And there we go. That's a deductive argument. Okay. Summarize. How could the definition of the corresponding angles be stated in terms of translations or reflections of the plane? And there you go. How could the definition of alternate be stated in terms of translation or reflections of the plane? Okay. And so this is corresponding angles can be defined as a translation by the distance between parallel lines. Alternate interior angles would be a reflection across the transversal and a translation at a specified distance. Okay, so it's a reflection across the transversal. We take angle 4 and reflect it, and then move it up. So I can kind of do here. So if you take angle, let's take angle 2, and I'm going to reflect it over that line. And now it's right here. Move it. And I'm going to move it. So angle 2, reflect it. So you're here now. And then, wait. How am I going to reflect that? I need to get it lined up here. So if I reflect it here, move it down. Oh, I see. Reflect it there, and then similarly here. Then we need to reflect it this way. Move it over. Yeah. All right. Go ahead and reflect it and then move it over. There we go. Okay. Extra example. Solve for x. Well, you can go ahead and use the fact that these are corresponding angles. They add to 180. When we do that and solve, we're going to get 45 degrees. And define the relationship among angles 1 and 2 using transformations. So if angle 1 and angle 2 are clearly congruent because they're corresponding angles, and if I move angle 1 to angle 2, if I translate it, it'll line on top of each other. If I go from angle 1 down to angle 2, I'm going to go to the left 2 and down 2. So that would be the translation vector right there. And there we go. All right, that is lesson 2.6.